Hi everybody. Next we are going to discuss about the CMOS technology, main fabrication of low cost. That is a local oxidation of silicon material. So the photoresist of the mask is removed here because in the previous steps we are using the UV light. We are both N well and P well is removed, that N well is forming, and the next the silicon dioxide and the silicon nitrate layer will be inactive. So the field oxide fox will be formed in between this N-well and P-well material. So the oxide grows in both vertical and lateral directions. So automatically the width of the material will be thin. So as a result, in active the area will be very smaller comparable to the previous one. And then the silicon oxidation is obtained by the heating of up to the vapor of 900 to 1000 degrees Celsius. It's a rapid process. So rapid process in the sense sudden heat, sudden cooling. That is a rapid process. And then we go for the dry oxidation process. There's a fluid oxidation, and it's around 1200 degrees Celsius. It's high temperature. Required to accomplish the growth of rate of the silicon dioxide. And also having the oxidation consumption in the silicon, mainly the SiO2 has approximately twice the value of the silicon dioxide. And also the Fox will be recorded in between that leads to the below in between the silicon surface of Fox. So this the Fox field oxide having the silicon surface with the silicon wafer with field oxide. So it is around, it's a 0.54 to 0.46 of Fox values here. And then gate oxide growth. So mainly the nitrate of stress relief oxide will be removed here, and also its device to threshold voltage of adjusted by the adding of charge with the silicon dioxide or oxide interface in between the two materials. So automatically the well is controlled in the gate oxide because it is directly connected to the oxide, and also it will be very thickness, the thickness value of T ox OX value here. And also the CMOS fabrication techniques, we have the polysilicon deposition and patterning is very important process. The layer of polysilicon deposited over the entire wafer surface, and the polysilicon is patterned with a lithographic sequence, and the MOSFET gated in the define of single steps. And also the polysilicon gate can be dropped, that is N plus, where being the deposited, and the lower parasitic resistance. This is the main important parameter in the CMOS fabrication sequence. And also the PCMOS, that's a PMOS information. And also PMOS representation in the P region, having the beam creation in between the P source and the drain regions. The polysilicon serves as a mask by underlying the channels, mainly called as a self-aligned process, and also precise the placement of the source and the drain regions. And the P-type material is formed here. It's like it's a dark layer is available. And also NMOS formations, mainly the photoresist is formed of N regions in the donors, that is arsenic or phosphorus of ion implanted in the N-type material. Mainly the process of self-aligned materials also available. And the gate type of the terminal is also available. And the doped N-type doped, that's N plus implant is available in the arsenic or phosphorus N material in L well. So it is a photoresist is formed here. And annealing is a very important process in the IC fabrication. Mainly after the implementation of completed thermal annealing, the cycle is executed. It allows the impurities of diffuse the further in the values, keep the remaining process at the step-by-step process, and having this temperature as possible, having N positive and P positive in the available in the envelope mass, and so finalized structure here. And also contact cuts is also very important. The surface of the IC is covered by the layer of CVD oxide, and the oxide upon the low temperature and LTO. and avoid underlying doped regions also is going in the defective spectration. Those allow the material contact diffusion on or the polysilicon regions is very important here. It's NMOS contact material we are using here, and also it's a metal 1 and metal 2 mask 1 is available. So p-type and n-type material is used in the metal 2 also. It is interlinked with like it's a connectivity of this p-type and n-type material. This the over glass of pad opening is available in the solid of silicon dioxide. This is the surface of CMOS fabrication step-by-step process. This is the final structure of the CMOS fabrication process is available in the polysilicon. So this is the finalized structure of sketch diagram of CMOS fabrication process in both PVL and NVL technologies. This the contact link is established in between P and NVL material of silicon dioxide. Thank you.